All right, guys, here we are on page 37 of your notebook, and these are violations of the octet rule. So some compounds will be able to actually violate the octet rule by either having too many or too few electrons. In these samples that we're giving, it's actually going to be a case where they actually have too many electrons. And this is because of d orbitals. Now, d orbitals are going to allow these atoms to actually pull up more than an octet when bonding, okay? So like we did before, I'm going to go over the first two problems, the example and one of the practices, and then the other two I would like you to stop the video and then try on your own. Okay, so for the first one is SeCl4. We're going to use the exact same setup as we have on all of the other ones. So we start by first getting a count of valence electrons. Se, that is going to be you should have your periodic table open. I guess I should have mine as well. Se is over in the group with oxygen. So looking at its last digit is 6. So Se, there's 1 in the formula, times 6 valence electrons gives 6. For chlorine, we have 4 of them in the formula. Each one has 7 valence electrons, and that's going to give us 28. When we add those together, we get our total of 34. Okay, so then the central atom in this case should be obvious. There's only one Se, so that's the one that goes in the middle. 4 chlorine should be around it. And when I subtract, I'm going to subtract 2, 4, 6, 8. That is how many electrons we used in bonding. And that leaves me 26 electrons left over. Now, again, we're going to start with the outer atoms where we're going to start distributing our lone pairs. So chlorine is going to get 2, 4, 6. Each chlorine is going to get 6 valence electrons. Okay, and then 2, 4, and 6. Okay, so all together, all those dots used up 24 electrons. That's going to leave me 2 left over. So those 2 leftovers are actually going to go as lone pairs on the central atom. Don't separate them because, again, they're supposed to be paired whenever we're talking about bonding. So that little lone pair of electrons will be right there on selenium. Again, because of selenium's location on the periodic table, that places it in the 4p energy level right here, which means that it actually has that 3d energy level that allows it to have an expanded octet. Okay, I'm actually looking at number 7 right now, practice problem, and realizing that one does not violate the the octet rule, but we'll work that one anyway, okay? So again, Se in the formula has 1, and it's in group 16, so we have 6 valence electrons. Bromine, there are 2 of them in the formula. Each one has 7 valence electrons. That'll give us 14. And then when I add those together, we get 20 total valence electrons. Again, Se is obviously the one that goes in the middle. There's only 1 of them, and we want to be as symmetrical as possible, okay? So Br minus, 4 electrons have been used for bonding. That's going to leave me 16 electrons to distribute. So those 16 electrons, we're going to start off by distributing to the bromine. 2, 4, 6, 2, 4, 6. Okay, so then that has used up 12 electrons, leaving me with 4 left over. Since both of the bromines already have an octet, that tells me that my 2 lone pairs are going to be given to selenium. Okay, try the last 2 on your own, PCl5 and SF4. Again, keep in mind that these are going to be violations of the octet rule.